So this is part 1 of the Chapter 1 practice test. It covers sections 1.1 through 1.4. And always, when I create a practice test, it's designed to be the best study guide for the tests that you're going to get in class, meaning that I should never ever put something on an in-class test that isn't just like the practice test. So if you can do all the problems on this practice test, you should be completely ready to do the test. Of course, there's going to be 2 parts because the chapter has 7 sections as opposed to 4. And right now, you should just be ready to focus on part 1. The best thing you could do is before watching the video, try to do the practice test, and then watch the video kind of with your answers in hand, just to make sure you're kind of on the thinking the same I am. So problems 1 and 2 give me sets that contain only natural numbers, and they want me to write word descriptions. Somewheres in my description, my word description, which is maybe a sentence to describe the elements of the set, I should probably use the word natural numbers for both 8 for problems 1 and 2, because the numbers are natural numbers. If I don't say natural numbers, that might allow decimals or negative numbers that I don't want. So for this problem 1, I might say set A, or A is, how about A is the set of natural numbers. And now that only excludes, the negative numbers, the decimals, and the fractions. It doesn't describe these numbers. And I would say the numbers start at 8 and get bigger. And probably the nicest way to say that in words, it might be using the words greater than or equal to 8. Because I need the equal to include the 8. And then the greater than part gives me the 9, 10, 11, and 12, and so forth. There are certainly other correct answers to problem 1. When I did the video over section 1.1, I might have written 2 or 3 answers each time I was asked to do a word description. On the practice test here, I'm only going to do 1 example. And if you have a different answer than mine, you're more than willing, you can just show me the answer and I could tell you whether I'd call that correct or not. When I do question 2, I might start off saying B is the set of natural numbers again, because the numbers 8, 9, 10, and 11 are natural numbers. And then, because there's a highest and a lowest number, I usually use the words between in my description. So instead of having a greater than or equal to, I'm going to say between. And the way I like to do the between problems is I like to state what the first and the last number are. And, of course, we have to put one more word to make sure that we're counting the 8 and the 11 and not excluding the 8 and 11, and that's the word inclusive. Generally, when I'm asked to do a word description, when we have a set that has a highest and lowest number, I use exactly this sort of word description. Again, if you have a different answer, that doesn't mean it's not correct. Just show it to me if you're not sure whether it's correct or not. 3 and 4 want me to do set builder notation, and set builder notation is my least favorite. The set builder notation is going to start off with the set brackets, and inside the set brackets you have a vertical line. I read this as A equals a set of all something with the property that. Usually before this vertical line, unless I have a reason to use a different letter, I use the letter X. And then after the vertical line, I write symbols to describe the elements of the sets. Just like in problems 1 and 2, these are natural numbers. And the nice way to say that the set only contains natural numbers is to use X as an element of n. You could, right here, you could say X is a natural number. So you'd have a little bit of flexibility. I'm writing the slickest answer I can think of. If where I wrote that symbol X as an element of n, you wrote the words X as a natural number, that would be completely fine. I'm going to follow it by a comma, but if you wanted to use the word and instead of that comma, that would be fine. And then after the comma, I need to describe the numbers, and those are the numbers greater than or equal to 8 again. I don't think there's probably a nicer way to describe the numbers other than their natural numbers and they're greater than or equal to 8. This part after the comma or after the and, I wouldn't probably write any differently. So an alternate choice might be able to do an answer like this. A equals the set of all x with the property that x is a natural number and x is greater than or equal to 8. That's actually the easier of the two. When we have a set like number 4 and we need to do set builder notation where we have a lowest and a highest number, we usually, when we get to the right hand side, have to put an x between those numbers with less than signs. But let me get started with this. So for set builder notation, I'm going to write the name of the set followed by the squiggly set brackets, and then I'm going to put an x in a vertical line. So this reads P equals the set of all x with the property that, and I need two things. I need x to be a natural number. Two ways I can do that. I can write, you can use the symbols for x as a natural number, or you could use the words, whichever you prefer. I like the symbols because it's easier to write, but what I'm about to write now would be one of these two things would be correct. After this, I could write a comma or an and. I like the comma. And then the hard part is to show between 8 and 11 exclusive. Usually in these set builder notations where we have a range of numbers, we have a highest and a lowest number, we put an x between the highest and the lowest number, and the only kinds of symbols that we put between the numbers and the x's is either less than or equal to. Less than would definitely fit for the word when the word in the problem after the numbers is exclusive. Less than or equal to would be the word that I would the symbol that I would choose if this word was inclusive as opposed to exclusive. Because it's exclusive, I'm just going to put less than signs. That's the answer I would come up with, number 4. There's definitely other correct answers. But not one that I would write. The next 3 problems want us to do the third kind of writing for sets and write the set in roster form, which is my favorite form. I just have to list the numbers in the set. That's what I'm asked to do for problems 5, 6, and 7. So I'm given some either word description or set builder notation to describe a set, and I'm asked just to list the elements in roster form. So for question 5, I'm going to write the set name, which is A, followed by an equal sign, and then I'm going to put some set braces, and inside the set braces I'm going to write all the numbers that are in the set. And the numbers in this set A are natural numbers, so I'm not going to have any decimals or fractions or negative numbers, and they have to be greater than 4. So I'm only going to put numbers that are essentially positives without decimals or fractions, and I'm going to start with the first natural number greater than 4 because I'm not allowed to include 4 because it doesn't say or equal to 4. So I'm going to start at 5 and get bigger. Since there's no end number, this pattern needs to go on forever. At some point, I stop writing numbers and I write ... to indicate the pattern goes on forever. 3 is the minimum number that you could show to establish a pattern. So probably on my key, if this was a test question, my answer would look like that. A equals the set 5, 6, 7, and so forth. But what I have above is equally correct. For question 6, again, the name of the set is A. It only contains natural numbers. So when I go to list the elements in roster form, I won't have any fractions or decimals. I see between 7 and 11, and then the keyword inclusive, which means in my listing, I'm going to do all the natural numbers between 7 and 11, and I'm going to include the 7, and I'm going to include the 11. If it said exclusive, my answer wouldn't have the 7 or the 11 in it. So I'm just going to write A equals, I'm going to write 7, 8, 9, 10, and 11, which are all the natural numbers between 7 and 11, if I include the 7 and the 11. If the problem said exclusive, then that answer that I gave is an answer for an inclusive. I can't even spell that this morning. If it said exclusive, my answer would have been A equals just 8, 9, and 10, because exclusive would include the numbers that were mentioned. On the test, I would feel comfortable doing either. I scratched out B because it wasn't written quite right, and I just wrote it how it should be written, and I should fix it on my computer quickly here. So B is a set of all x such with the property that x is a natural number and x is between 3 and 7, includes the 3 because of the or equal to, doesn't include the 7 because of no or equal to there. So I know that for set B, I'm only going to put natural numbers, and I'm only going to put the natural numbers between 3 and 7, and an or equal to means to include that number. A not or equal to with the inequality means to exclude that number. So I'm going to put all the natural numbers between 3 and 7. I'm going to include the 3, but I'm not going to include the 7 in my answer. So instead of writing 3, 4, 5, 6, and 7, I'm only writing 3, 4, 5, and 6 because I'm excluding the 7 because it doesn't have an or equal to with its inequality. 8, 9, and 10 want me to find the cardinal number of a set, and the cardinal number is just the number of elements in a set. So in order to answer questions 8, 9, and 10, I need to know the elements of the set. So first, for problem 8, I'm going to find the elements of the set, and then my answer isn't going to be what the set that I constructed. It's going to be the number of elements in that set. So in problem 8, B is a set of natural numbers between 5 and 7, inclusive, including the 5 and 7. So B is the set that contains the numbers 5, 6, and 7. That's writing the set in roster form, although I didn't do anything wrong. I didn't answer the question. The question is, was the cardinal number of the set? And when I go to write my answer, a slick way to write my answer would be the small lowercase n followed by a parentheses with the set name, and then an equal sign, and then the number of elements in that set would go after the equal sign. There's 3 elements in that set, and that would be fine. Another way to write the answer, you can say the cardinal number of set B is 3. If you wanted to be super lazy, you can just write the number 3. So all of these would be okay. All what they have in common is they tell me the number of elements in the set, which is 3. Just as long as you get the 3 right and your answer isn't the specific set itself, will be fine. For question 9, I need to create the set that's described here. Set A is a set of natural numbers less than but not equal to 5. Natural numbers start at 1. So the numbers in set A here are any natural number that's less than 5 but not equal to 5. This is what set A is. It's a set that contains the numbers 1, 2, 3, and 4. All those are the only natural numbers that are less than 5 and not equal to 5. For my answer, probably the laziest answer would be just to write the number 4. There's 4 elements in the set. If I want to do something a little bit nicer, I can do the lowercase n with an A in a parentheses and say the number of elements in set A is 4. And if I cared to write a sentence, I could write a sentence like this. I could say the cardinal number of set A is 4. Problem 10 says find the number of elements in set C, or find the cardinal number of set C, where C is the set that has the letters W, X, Y, and Z. The simplest answer for this, I could count that set up that has 4 elements, would be that. Another correct answer would say the cardinal number of this set C is 4. And the last correct answer, I could say the number of elements or the cardinal number, which is the same thing as the number of elements of set C, is 4. All of these are equally correct answer to problem 10. 11 through 13 want to ask me if sets are equal or equivalent or neither. Equal means they have exactly the same elements. When I look at the sets in problem 11, both sets have the numbers 1, 2, 3, and 4. So one of the things in my answer for problem 11 is I need to say that these two sets are equal. I'm supposed to determine whether the sets are equal. And to be equal, you have to have exactly the same elements. Both sets have a 4. Both sets have a 3. Both sets have a 2. And both sets have a 1. And they have exactly the same elements. There's no extra element in one set as opposed to the other. So those are equal sets. To be equivalent, you just have to have the same number of elements. And in question 11, set A has 4 elements, set B has 4 elements. When two sets have the same number of elements, they're equivalent. So for problem 11, the sets A and B are both equal and equivalent. That's the whole answer for 11. For problem 12, the sets aren't equal because they don't have the same elements. A, B, and C aren't exactly the same as 1, 5, and 9, so they're not equal. But both sets have 3 elements. They have the same number of elements, so these sets are only equivalent, but they're not equal. The answer to problem 12, it just needs to be the word equivalent. You don't need to have the only there, but I just kind of wrote it. And then for 13, they're not equal because B has a 2 in it, and there's no 2 in A, so they can't be equal, because to be equal, you have to have exactly the same elements. B can't have an element that A doesn't have for it to be equal, so they're not equal. And they're not equivalent because A has 2 elements and B has 3 elements, so they're not equal. They don't have exactly the same elements. They're not equivalent. They don't have the same number of elements. The answer to this must be they're neither equivalent nor equal. So my answer to 13 is going to be neither. So I just slightly modified problem 14 because I modified the problems in the video before I actually shot this. So answer yes or no. If no, give the reason. Is A a subset of B, given A is the set that contains A and B is the set containing A, B, and C? For this symbol to be true, remember there's 2 things. A needs to be a set, and to be a set, you just need the set braces. So A is a set. I satisfied rule 1. And the second thing I need for this symbol to be true is that every element in A is also an element in B. And there's 2 elements in A. A is an element of A, it's also in B. B is an element of A, it's also in B. So I'm going to answer, is A a subset of B given this? My answer to this is going to be yes. And because it's yes, I don't need to see a reason why it's not. When I look at this situation here, is A a subset of B given A is the numbers 1 and 2, and B is the set containing 1, 2, and 3? Rule 1 in this case says A needs to be a set. And this is not good because A is not in set notation, so A is not considered a set. My answer to this is going to be this is a false statement, or it's no. And the reason why is because A is not a set. (16) says, is A a subset of B given A is 2, 4, 6 and B is 1, 2, 3? Well, I need 2 things. I need A to be a set. That's good because it's in set braces. 2, I need every element of A to be an element of B. And this is where I mess up, because 4 and 6 are in A, but they're not in B. So I violate rule 2. My answer to this question is going to be no, because there are elements in A that are not in B. And to be a subset, A has to be a set, and every element in A has to be in B, which it isn't here. All right, now the icky problems. Determine which of these are true. So we need to know what it means for each one of these symbols to be true. So I'm going to go one at a time. For 17, I'm going to see if the two sets A and B are equal. And we just talked about equal recently. Equal means they have exactly the same elements, so this is going to be a true statement. Part of my answer to 17 is going to be those sets are equal. For this symbol, to see if it is true, to see if A is a subset of B, I need two things. A has to be a set, which is, and every element of A has to be in B. So to be a subset, there's just two criteria. First, A is a set. Now every element in A needs to be in B. 5 is in A, 5 is in B. 7 is in A, 7 is in B. So I've satisfied both of those. So this is also a true statement. So I'm done with those two. Let me move on to this one next. We haven't talked about that on this video. To be A as a proper subset of B, I need to satisfy both those rules. And in addition, there's a third rule that says A can't equal to B. And this one is going to be false. It's not true because this one doesn't allow the sets to be equal. So I'm not going to, in my answer, I'm not going to include that because you have three rules you need to satisfy. The two rules of being a subset and the additional rule of not being equal. Let me do for B as a subset of A. For B to be a subset of A, you have rule 1, B has to be a set, and B is a set because it's in set braces. For rule 2, every element in B is also in A. Let me look at the two elements of B. 7 is in B, 7 is in A. 5 is in B, 5 is in A. The two elements in B are in A, so this symbol is going to be true and it's going to be part of my answer because it satisfies the rules. The only symbol I haven't looked at yet is this B is a proper subset of A, and for B to be a proper subset of A, you need to satisfy rule 1 and rule 2, and also the rule 3 that doesn't allow the sets to be equal, and because the sets are equal, it violates rule 3. That can't be included in my answer. The answer to problem 17, these are the three symbols that are true. To do 18, I need to figure out what the sets are. A is going to be the set of natural numbers that are in between 1 and 5, not including the 1 and not including the 5. The natural numbers between 1 and 5 are 1, 2, 3, and 5, but because I don't see there are equal twos, I'm only going to count 2, 3, and 4. So A is going to be the set 2, 3, and 4. One symbol at a time now. Let's look at A equal to B. When I look at A and I compare it to B, for the equal to be true, they'd have to have exactly the same elements, and B has a 5 that A doesn't. They're not equal. Next one I want to look at to see is A a subset of B. Without writing it down, I'm going to do the two rules. First, A has to be a set, and it's a set. Second rule, every element of A is also in B. 2 is in A, 2 is in B. 3 is in A, 3 is in B. 4 is in A, 4 is in B. It's a subset because it's a set, and every element in it is in this B, so this is going to be part of my answer. The one I like to do next is A is a proper subset of B. To be a proper subset of B, you have to follow the two rules of being a subset, and the sets can't be equal. So there's three rules. First, A has to be a set, which it is. Second, every element of A, 2, 3, and 4 has to be in B. And the third rule to be a proper subset is the two sets can't be equal, and these two sets aren't equal. So that's going to be part of my answer. Let me do now B is a subset of A and see if that works. For B to be a subset of A, there's two things that has to happen. B needs to be a set. It is, because it's in set braces. And the second thing I need is every element in B is also contained in A, or in A. And this is where I'm going to mess up, because B has a 5 that's not in A. I violate this, and that symbol's not going to be part of my answer. The other one of these I haven't checked is B is a proper subset of A. And for B to be a proper subset of A, you need to satisfy the two rules of being a subset. Because the second rule is violated of being a subset, it doesn't satisfy all three rules because it doesn't satisfy the second rule. I can cross that one out. And my answer to problem 18, the only two of the symbols that are true are the A is a subset of B and A is a proper subset of B. Okay, now the part that I like a lot better. 19 gives me a universal set, a set B, and wants me to find B complement. To find B complement, I just go inside the universal set, scratch out the elements of B. What I haven't scratched out is what's in B complement. B complement is going to be the set that contains the letters A and D. 20 wants me to find A, set A intersection B complement. Well, set A is the set that contains A and B. I'm going to leave this intersection problem symbol, and then after the intersection symbol, I'm going to write what B complement is, which is a set that contains A and D. The intersection of two sets is what the sets have in common. Those sets both and only have the letter A in common. My answer to problem 20 is going to be the set that contains the letter A. For 21, I want to union the A set with the B complement set. To do this, I'm going to write down in place of the A set, the set containing the letters A and B. Then I'm going to write my union symbol. And then in place of the B complement set, I'm going to write the set containing A and D. When I union two sets, I take all the elements in the first set and all the elements in the second set. I write them together in a big set. And then I look to see if there's any duplication, because every element only needs to be listed once. I have two A's listed. I only need to have one A listed in my final answer. My final answer as to what the set A union B complement is going to be the set containing the letters A, B, and D. One last page of problems, just two more problems to do. More unions and complements and intersection problems. For problem 22, I need to do the parentheses first. And the parentheses want me to do T union V. Let me just kind of do it off to the side here. To do T union V, I take the entire T set, which is 1, 2, and 3. I union that with the V set, which is 3, 4, and 5. When I union two sets, I take all the elements in the first set and then all the elements in the second set, and I write them in a big set. And then any number or element that's listed twice, I only write it once. So T union V, the parentheses part of this, is going to be the set containing the numbers 1, 2, 3, 4, and 5. So for the problem that I'm asked to do, I'm asked to find S intersection T union V. I can drop the parentheses and change the T union V to the set containing the numbers 1, 2, 3, 4, and 5. Now I'm going to take the S symbol and change it to the set containing the numbers 1, 3, and 5. I'm going to leave the intersection symbol, and I'm going to leave the 1, 2, 3, 4, and 5 in place of the S union T. And now I'm going to find the intersection. When you're intersecting two sets, you're finding what the sets have in common. My answer to problem 22 is what I get when I intersect those two sets that I've just kind of hinted at, what I'm going to get for an answer. Intersections are what sets have in common. Those sets have the numbers 3 and 5 in common. For problem 23, off to the side, the first thing I need to do is V complement intersection T. I need to know what V complement is. To find V complement, I'm going to go to the set of the universal set, and I'm going to scratch out the elements of V, which are 3, 4, and 5. When I scratch those out, what I haven't highlighted are the elements of V complement, which are 1, 2, and 6. So to figure out what's inside my parentheses, I need to take my V complement set, which is a set that contains the numbers 1, 2, and 6, and intersect with that T set, which is a set that contains 1, 2, and 3. And when you intersect two sets, you write what they have in common, and those two sets have the numbers 1 and 2 in common. So the parentheses here I'm going to change to the numbers 1 and 2. I can rewrite this problem as S union, drop the parentheses, drop the letters, and change it to the set containing the numbers 1 and 2. Now I'm going to change the S to 1, 3, and 5. I'm going to leave the union symbol between the sets. And now I'm going to union these two sets. To union two sets, I take every element in the first set and every element in the second set. I join them in a big set. If any element's duplicated, I only need to write it once. The answer for my problem 23 is going to have the numbers 1, 3, 5, and 2. I like writing my numbers or letters alphabetically, my numbers in ascending order. So my answer, I would write 1, 2, 3, and 5 for the set that represents S union the quantity V complement intersection T. All right, so that's everything on the first part of our practice test. So get these down really well before you move on to the second part, which covers sections 1, 4, 1, 5, 1, 5, 1, 6, and 1, 7.